good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. Let's look at another question under electrostatic force. So we are told that two metal spheres X and Y on insulated stands carry a charge of 3 times 10 to the power of -9 coulomb and negative 6 times 10 to the power of -6 coulomb respectively. Let's fill that. Why am I taking that numbers, man? Respectively meaning X and Y, meaning this will be X and Y. So yeah, not confuse that. This will be, or initially it is, I want you to see something. Initially it is 3 times 10 to the power of -9 coulomb. This is -6 times 10 to the power of -9 coulomb. When this happens, if they are allowed to touch, there will be a transfer of electrons from what? From the one that is more negative to the one that is less negative. Okay, so here are the transfer of electron from the one that is more negative to the one that is less negative when they are allowed to touch. Okay, therefore now after that, after they are allowed to touch, after having a new okay, after getting in contact, there will be a new charge on them that will be equal. Okay, therefore they are placed at the distance like that. Okay, so now remember there will be a new charge that they will now have. Q new will be this one, which is 3 times 10 to the power of -9 minus 6 times 10 times 10 to the power of -9 divided by 2. Then it is -3. I get -1.5 times 10 to the power of -9 coulomb. Let me quickly confirm that. 3 times 10 to the power of -9 minus 6 times 10 to the power of -9 divided by 2. Very, very good. This is their new charge. So this is their new charge after a contact. Okay. Nanocoulomb, remember, is the same as times 10 to the power of -9. State Coulomb's laws in words. The magnitude of the electrostatic force between 2-point charges is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. Okay, that is the definition. You should be in a position of knowing it. Then 6.1.2 is saying, in which direction will the electrons flow while sphere X and Y are in contact? From the one that is more negative. Which one is that? It is Y. So it will move from Y to X. I also showed that here, right? The electrons will move from Y to X. Calculate the net charge gained or lost by sphere X after the spheres has been in contact and back to the original position. First thing first, you need to calculate the new charge. Let me take this. First thing first, you need to calculate the new charge, which we did that precisely, nicely. Let me take that and say, let me answer the question then. And say, let me answer the question. Okay, let me just say this is 6.1.3. Again, this is the new charge. But now they say calculate the net change. So the net charge gained or lost by sphere X. Okay, after the spheres has been in contact. Calculate the net charge gained or lost. So now sphere X, what happened to sphere X? Sphere X gained again. So how much did it gain? How much did it gain? We're going to say change in Q of X. Okay, it's going to be Q final minus Q initial. What is the Q final? Q final, it is -1.5 times 10 to the power of -9. What is the initial change? The initial change, sorry, the initial charge, it is how much? 3 times 10 to the power of -9. So this has a net charge of how much? -4.5 times 10 to the power of -9. Okay, so this is the number of electrons it acquired. Okay, so this one acquired. Remember, if this one gained electrons, this one lost electrons. Why am I saying this one gained electrons? Because it was more positive, but now it is negative. How many electrons did it gain? It gained 4.5 times 10 to the power of negative 9 electrons. This one lost how much? How much? 4.5 times 10 to the power of negative 9. Okay? Yes. Yes. Qx, final, it is that one, then that one. So now, 6.1.4 says, calculate the number of electrons transferred. Calculate the number of electrons transferred. The number of electrons transferred, remember, it is number of electrons transferred, it is charge or change in Q divided by charge of an electron. Okay, number of what transferred is going to be, and you can use negative 4.5 times 10 to the power of negative 9. But when you use negative 4.5, you need to divide by negative 1.6 times 10 to the power of negative 19. If you use positive here, it needs to be positive also. And it is equal to what? 4.5 times 10 to the power of negative 9 divided by 1.6 times 10 to the power of negative 19. I get the number of electrons that we transfer as 2.81 times 10 to the power of 10. What? Electrons. Very, 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 very interesting. Remarks. There of 3 marks, how do you get it? 1 here, 1 there, 1 there. Okay? Calculating the charge formula, substituting into that formula, then coming here and finding the change in X, therefore the final answer thereof. Then they are telling us a third metal sphere W is carrying a charge of negative 3 times 10 to the power of negative 9 coulomb is now placed between X and Y. Between X and Y, okay? Between X and Y at a distance of 0.1 meters from Y. 0.1 meters from Y. So 0.1 meters from Y. Therefore, it means this one will be 0.5 meters. So if I place that here, okay, let me enlarge that. If I place W there, it should be now at a position where it is 0.1 meters from, not 0.1 man, so Raskis. 1 meters from Y, okay? If it is one, and it is between, okay? If it is between and it is 1 meters away from Y, therefore it means it is 0.5 meters away from X, because so the total length should be 1.5. Then they say to us, calculate the net force experienced by W due to X and Y. The net force, okay? The net force that W experienced due to X as well as it experiences due to Y. The charge here, it is negative, then it is also negative. So now it will feel a repulsion force fail, okay? So we will say F net let's calculate the force that X exerts on Y, okay? And it is towards the what? This one, X will cause Y to move towards the right, okay? This will be the force that X exerts on Y. If I draw a free body diagram, then Y will cause X to go, Y will cause W to go where? To go in that there, like it is opposing, so it will be force of Y on W. Why? I repeat, what will X cause W to do? They will repel. This will go there, that will go there. But since when we are calculating the net force of W, we are concerned about the direction of W. It's going to be to the right. Therefore, if it is between this one, between the two, they will repel like that. But we are concerned about the direction of W. So can you see? Force XW is going to be K QW, QX divided by the distance between them, which is 9 times 10 to the power of 9. Charge of W, they said it is how much? Negative 3 times 10 to the power of negative 9. We just say 3 times 10 to the power of negative 9. Charge of X, this one, okay? It is 1.5 times 10 to the power of negative 9. Divide by the distance between X and Y. Between X and Y, the distance, it is 0.5. I need to square that. How much do I get? Let me quickly grab my calculator and punch that. 9 times 10 to the power of 9. Multiply by 3 times 10 to the power of negative 9. Multiply by 1.5 times 10 to the power of negative 9. Like that. Then divide by 0.5. I need to square that. Then I get something like 1.67 times 10 to the power of negative 7. Why am I getting negative 7? Newtons. Where is force of X to W? It is good to the right. To the left, to the right, to the right, to the right. Let me take this. Okay. I've already calculated the force. Okay, I need this. This is the force of XW. Then let's calculate the force of YW. Change this to just being Y and still R squared. Let's see how much we get this time. 9 times 10 to the power of 9. QX. No, sorry, QY. Hey. QX is still the same. Remember, the charges are the same for this one and this one after contact. Okay? Remember, this is also negative 1.5 nanocoulomb. So it is 1.5 times 10 to the power of negative 9. Then that one, it is 3 times 10 to the power of negative 9. This is just only 3 years. Remember, negative, we do not accept negative in this formula. Divide by R squared. R squared, distance between Y and W, it is 1 squared. Then how much do I get? I get something like 1 squared, something like 4,05, sorry, times 10 to the power of negative 8. Where is it moving? F, Y, O to X, it is to the left. Then I'm taking that, put it here. Then I say, okay, now let's calculate the F net now. Now let us be in a position of saying, therefore, F net, it is equal to force X on Y plus force Y on X. We choose right as positive. We need to choose the direction, okay? Therefore, if we choose right as positive, it means this one will be 1.67 times 10 to the power of negative 7 minus Y, because this is moving to the left. 4.05 times 10 to the power of negative 8. How much do we get? 1.67 times 10 to the power of negative 7 minus my answer. Okay, let me do minus 4.05 times 10 to the power of negative 8. I get a answer of 1.265 times 10 to the power of negative 7 newtons. It is positive, therefore it means to the right. Did they say the magnitude? They said the net. The net. Remember, the net, it is a vector quantity. It needs to have a direction as well as magnitude. So that is it. That is it. Okay? Yes. That is it. So thank you very much. I hope you enjoyed it. Let's meet on the next video.